Welcome to Mimi's Math Channel. Today I will discuss graphing linear functions, and below you will see things that you'll need to understand before we proceed. So slope-intercept form is when the y is isolated to the left and it's set equal to mx plus b, where m represents your slope, b represents your y-intercept. That's going to be helpful when you're trying to graph. Ordered pair is when you see coordinates that are set up in parentheses where x is first and then y is second. And again, this is helpful when you're graphing because you have an x-axis and a y-axis. X always comes first and then your y. X goes left and right, y goes up and down. Domain is going to be the set of the x values of the ordered pair. So whatever your x values are, that is going to be included in your domain. So let's go ahead and get started. For example 1, we're asked to graph the function for the given domain. So we're given this function here and the domain, which is my x values. So what I would suggest that you do is set up a table with 3 columns and then however many rows that you need for the given domain. So what that's going to look like is this. So what you will see in my table is I took my given domain and I listed in the first column. And then over here, I changed my function to slope-intercept form, which I'm going to demonstrate here in a few minutes because it should look like this. And then for my x values, which I said that's what my domain represents, I just replace those values with that x. So the first thing you want to do is you want to go ahead and convert your function that was given into your slope-intercept form, which means I'm trying to get y on the side by itself. So if I started off with 2x plus y is equal to 4, what I need to do is move this 2x over to the right-hand side. And anytime I move something from one side to the other, I have to use the inverse, which means to change the sign. So it initially was positive 2x. Now I want to change the sign to make it 2x, negative 2x. And the reason I'm doing that is because I want to zero it out, which leaves that y on the side by itself. Now on the other side, I can't combine the 4 and the negative 2 because negative 2 has an x after it. But I do want to put it in the form where the x comes first. So it's negative 2x. And it's understood to be a plus sign in front of that 4 if you don't see anything else. This is now in the slope-intercept form. So what I'm doing now is I'm looking at my second column here. And instead of having an x here, I'm going to replace it with each one of those values they gave me for my domain. So I'm just going to do the first 2, and then I will just show you what the other answer should be as well. So I'm going to replace that x for the first one with negative 3 because that's what I was told in my domain value or set of domain. So once I simplify this, negative 2 times negative 3 is positive 6, and then I'm adding 4 to it. So once I simplify that, 6 plus 4 is 10. When I'm setting up my ordered pair, this is what it looks like. Negative 3 was my x value that I used, and once I combined my terms or I simplified on the right hand side, it told me my value for y, which goes here. And again, that's helpful when I'm graphing because now I have some direction. Let's do one more. The next one said negative 1. So I'm just going to replace that same x, but this time with the negative 1. And now negative 2 times negative 1 is positive 2 plus 4 is 6. So when x is negative 1, my y is 6. And so this is what my table will look like now. So if I were to continue substituting in, this is what the other values will look like. So now my directions ask me to graph the function. So this is where this comes in handy. If I were to just graph it as normal without a given domain, it would just be a linear function. How do I know? Because my x, the degree for x is 1. It's understood to be a 1 there. So I can use this technique for absolute values, or I can use it for quadratic functions. I can use it for any type of function. Just make sure that you understand that if it has a degree of 1, that's going to be a line. In this case, since I have specific domain values, I'm not going to actually connect those points. I'm just going to use points for these specific domain values. All right, so that will be at negative 3 and 10. So where x is negative 3 and where y is 10, I have to see where they intersect. And once I see where they actually intersect, I can go ahead and graph a point there. So that's going to be right here for one of them. And because there's a 10, this is 10. All right, the next one says -1 and 6. -1 means go to the left 1 and then up 6. So 1, 2, 3, 4, 5, 6. And so therefore, I'm going to put a point here. And 4, negative 4. This time I go to the right, and then I'm going to go down 4. 1, 2, 3, 4. So make sure you understand that, how that works. And then I go over 7, and then I go down to negative 10. And again, this is 10 units down. So I'm going to go to 7, go all the way down to 10. And you would notice that it is going as a line. I'm just not going to connect it because, again, it told me only for these values. And I know that I'm on the right track because if I look at my slope is a negative value. So that tells me that my line is going to go downward. In addition to manually setting up your table, when you're ready to verify your answers, if you're using a TI-30XS calculator, that yellow one, then you can actually use these steps, and that will also help you to see whether or not you're on the right track. Moving on for example 2, we're asked to graph the function that looks like this. So what I want to do is, again, put it in slope-intercept form, which means I'm moving everything over to the other side of the equation that does not have a y with it. So the first thing I want to do is take the inverse of 12, which is subtracting, take the inverse of x, which is now adding. What I do to one side, I do to the other. So I'm going to go ahead and put the x first and then minus 12. Again, if I just put an x, it's understood there's a plus sign in front of it. Why did I do that? So I can zero this out and I'm left with negative 2y. On the other side, I have x minus 12. Y is not by itself. We want to make sure that y is on the side by itself. So what's stopping it? That negative 2. If you have something next to another thing, that means you're multiplying. So the inverse of multiplying is to divide. So we want to divide all terms by that negative 2. A term is what is before and after your operation. And operation is plus, minus, multiplication, division. So now negative 2 divided by negative 2 is 1, and we're left with y. And on this side is x over negative 2, which is really understood to be a 1 in front of that x. So we're just going to write it as negative 1 over 2, and then put the x next to it. A negative divided by a negative turns into a positive, and then 12 divided by 2 is 6. So now we see that this is in slope-intercept form. I can identify my slope by m. M, in this case, is negative 1 over 2. Well, slope means rise over run, so that means that I'm either going up or I'm going down, depending on the sign that's in front of my numerator. In this case, it's a negative 1. And my run means I'm either going to the right or to the left, and again, depending on the sign. If there is not a sign, it's understood to be plus. My b is my y-intercept. Well, y-intercept means that my x value is 0 when y is whatever this is shown as. If it was a negative 6, I would put negative 6, but it's a positive 6, so I'm going to put positive 6. This is my starting point. I want to actually go to my graph, and I want to go where x is 0 and y is 6. So I'm going to count up my units, 1, 2, 3, 4, 5, 6, and I'm going to place a point there. Now from that point, I am going to go down by 1 because it says to rise, and it's either up or down, and then I'm going to run over 2. So when I go down, I don't put a point. I wait until I do both steps first. I'm going to go down 1, and then I'm going to run over 1, 2. That's where my point's going to be. I'm going to do the same thing. Go down 1, run over 1, 2. Now, what I could have done is I could have said 1 over negative 2. Some people think you can't do that. This means the same thing, except this time I'm going to go up because there's a positive 1, and then I'm going to go to the left, which is a negative 2. So let's go back to our y-intercept, and let's try that. If we go up 1 and then run over to the left, 1, 2, you'll see I still have a point that's in line with my linear function. And this is, I could just keep going forever and ever if I wanted to, but what you would do is you would actually connect those points. And once you connect those points, put an arrowhead on both ends of it, and that indicates that this goes on forever in the same direction. Now I noticed that I have a downward slope this time, and that's true because it's a negative in front of it. If it was positive, it would be going upward. So let's move on to the next example. This is the last example. All right, so this time we're asked to use a graph of the function f of x is equal to 1/3 times x plus 1 to find the value of y when x is equal to 6. And then afterwards, we're going to check our answer. Well, I went ahead and went to Desmos and I typed in this function. And once you type that function in, this is what the line looks like. Again, linear functions, that's what we're talking about. So it says, what is y when x is 6? X is your x-axis going left and right. I want to go to where on my x-axis is 6, and I want to click on the point and see, let's see if we can find it, there we go. I see that when x is 6, y is 3. So that means over here, y is 3. If you can't really tell what it is, you can actually click on this little wrench settings, and for your y-axis, change this to tell it you want to count by ones. It's currently counting by twos. So now you see it changed. So you can kind of see where 3 and 3 is on the y-axis and 6 is on the x-axis. That's where they come together. And again, usually you can click on it and it'll show you. So 6 and 3. So we know that the value of our y based off of our instructions is going to be 3. But we're also asked to check it. So this is where we will go back to like example 1 when I set up a table and my table had 3 columns. You don't have to do all of that, and also remember that y means f of x. It's interchangeable. So I'm trying to find my y value when x is 6. So I'm going to go ahead and substitute in that 6, and that will give me my y. I already know that my x value is 6. And this, if I were to simplify this, this is really 1 times 6 divided by 3 plus 1. And remember, fractions are simply just telling you to divide. So 6 divided by 3 is 2. 2 plus 1 is also 3. So it didn't ask me for my coordinates. My final answer is, in fact, y equals 3. Thank you for watching. Please like and subscribe. Have an awesome day.
Subscribe.